Hi, welcome to Computing Foundations. This is the channel for beginners who want to learn about computers, programming, and the math, science, and art behind this world-changing field. I'm Josh Kilpatrick, a retired software engineer. Today, we're going to be learning a new concept in C programming called functions. Functions are a really important tool when you're writing programs because they allow you to write a piece of code, a block of code, and reuse it all over your program so you don't have to rewrite the same code again and again. They also have other practical benefits, but let's just start with that initial benefit. They allow us to write code and reuse it in different places in the program. All right. Let's take a look at just a definition of the functions. So functions are isolated segments of code that accomplish a specific task. Usually they take in data, what we call parameters, and they return a result back to the user. So let's take a look at that claim that I'm making about what is a function. So property one of a function, they usually take in data. Here I'm showing that this function takes in width and height, okay? And then property two, they usually return some sort of value. Here I'm saying I'm going to return area. And property three, I said here functions are isolated, or functions are, another word for that might be self-contained. Self-contained. So what is inside of the function isn't something that the outside user has to know about. The function isn't going to interfere with the rest of the program. For instance, in a lot of our programs, we've been calling the printf function to print something to the screen. Now, it wasn't really important that we know how the printf function accomplishes that. We just called the printf function, we gave it our string, and potentially we gave it some variables to print out, and we trusted that it would do that it would print it out to the screen. But the function's self-contained. We don't really know how it works, we don't know what's inside of it, and it doesn't have any impact on our program other than it prints something out to the screen. Let's continue and look at how do we actually define a function. Okay, a function gets defined like so. We start with a type. What I mean by a type is one of our keywords for variable types. Int, long, float, double, char, and also a special type called void we'll talk about as well. So we write a type here. We're saying this function is going to return a value of type, and depending whatever we write here, it'll return an integer, a long, a float, a double, a char. Okay? The next thing we do is we give the function a name. The rules for naming functions are just like variables. They can be letters, numbers, and underscore. No spaces, and it must start with a letter. So we define a name for our function. This is how we will refer to it in the rest of the program. Next, we open a parenthesis, and we have a list of potentially multiple or no, zero, parameters. This is the data that's going to go into the function. So we write one of our types, and then we write a name, whatever name we want for that parameter, and then a comma, and then we can write another type and another name. If we wanted, we could do a comma, and we could continue as many parameters as we want. Finally, we close the parameter list with a parenthesis, and then a curly bracket to open the body of the function. And then after we write the code of the function, the final statement is return. And we optionally put here a variable or a value that will be returned out of the function. And this variable or value must be of the same type as we specified here in the function's prototype, is what this is called here, the prototype of the function or the signature of the function. All right, so that's what a function looks like in abstract sort of definition terms. Let me show you an example. Look at this function that I've defined. Int, the function will return an integer. Name, calculate area. It is important to give your functions meaningful names about what they do, but you can name it whatever you want. My parameter list, I'm going to take 2 integers into the function, width and height. And now watch what happens. I'm inside the body of the function, and this is just like I'm writing another program. Just like a main function, I can just write in this function just like I'm writing any program. I can define variables, I can do arithmetic, and eventually I can do this return. So I define a variable area, I set it to 0, then I perform some arithmetic, area equals width times height. So notice this parameter and this parameter, once I'm inside the body of the function, I can refer to those by name just as though they're variables. They are, in fact, variables that are available inside the function. So every parameter of the function is a variable that's available inside the function. And I can define my own variables inside the function. Finally, my return statement, I return area. Notice area is of type int, and the return type of my function is type int. So this is a well-defined function. It does a specific task. It takes in a width and a height. It calculates the area for you and returns the area, the value of the area back out of the function. Let's look at another function that doesn't return anything. So I called this one print area. It's not going to return the area. It's just going to print the area onto the screen. And because I'm not returning anything, I can use this special keyword void, which means don't expect any value to come back out of this function. So again, I'm passing in width and height, defining an area variable, performing a multiplication to calculate the area, and then I'm printing out area on the screen. Finally, I issue a return statement without any variables or information after it because I'm not returning anything, but I'm just indicating return, the function is over. You can go back to where you came from. So this is 2 examples of what it looks like to define a function. Now let's take a look at where exactly in the program do I define functions. All right, I'm showing you here what a typical program looks like. We went over this in our program structure video already. Let's review. So a program file optionally begins with include statements that tell the compiler to include other program files into your file. It's as though you're picking up this entire file and you're placing it inside your file. You're including it inside your file so that you can use it and reference it. Next, we optionally define constants. We talked about this in our constants video. Here I'm defining a constant called sales tax, and I'm setting it equal to the floating point number 0.09. Next in the program, I can define my functions, my user-defined functions. Take a look at this. Void my function. It doesn't take any parameters. That's perfectly legal. I'm not going to return anything, and I don't require anything. And what am I going to do? I'm just going to print hello onto the screen. Now, I wrote this function all on one line just to keep my writing compact. Normally, you would start the body of the function on a new line just to make it easy to read. But remember, the C compiler doesn't care about whitespace, so this is perfectly legal. After I've defined all of my functions, I then define my main function, which is what we've been doing up until now in most of our examples. We've just been defining a main function. Now, the main function here, we always define it the same way. It returns an integer, and it doesn't take any parameters. We'll learn later that actually main programs can take parameters. We'll learn about how to do that in a later video, but for now, we're not taking any information into the main function. It's just going to run. And look at how I call my function. Just as though I'm calling a printf function, I just state the name of my function. I open and close the parentheses. If the function required parameters, I would place the parameters here. And finally, I do a semicolon to finish that function. And now here I'm printing out world. The result of this program will be hello, and then a new line, and then world, and then a new line. It's just occurring to me as I'm recording this that I'm not sure if I've ever explained that this \n is a special character in the printf function, which means do a return, go to the next line. If I omit the \n, it doesn't create a new line. So it just continues printing on the same line. Not a big deal, but I don't think I've mentioned that before. Okay, so this is where we define functions. We always define a function before we use it. We can't define it after we use it. The compiler won't know what we're talking about. So we have to define a function before we use it. All right. Now, another topic that we need to discuss that's now coming into view is what's called variable scope. This is an important feature of all languages, and let me walk you through it here now. So imagine a program, I'm trying to represent it here in a set of boxes. And what I'm trying to represent here is that there are these different scopes in the program. These are called scopes. So the program file itself, at the top of the file, it's perfectly legal to define constants and to define variables. There are only certain cases where we would want to define a variable that was at the level of the whole program. But if we did, this would be called a global variable. And it would mean every function that was defined in the program would be able to access and refer to this variable. Every function could change it or could read it. Okay? The next thing that we see in a program is we have our main function. And inside the main function, we have these curly brackets that open and close the function. This is called, whenever in C we have code inside of two curly brackets, we call it a code block. Okay. Now, what is important about a code block is a variable that gets defined inside of a code block is only visible within that code block. And we'll see an example of this and get a little more detail, but int main equals 0 is only available in the main function. It would not be available for other functions to refer to it. Okay? Now, let me show you a little more. What if I had a for loop inside my main function? And I'm going to set it, I don't write all the syntax here for the for loop, but I'm going to have a for loop that loops 5 times. And I also have a open bracket and a closed bracket. So I've created another code block, another scope. This variable, int for var equals 0, okay, is defined in this scope, only in the for loop. The main function cannot see it. Now, but look at this. The for loop can see the main variable that was defined in the main function. It can say main equals main plus 1. It can access this main variable inside the for loop. It could also access this global variable. If we wanted to mention the global variable here and increment it inside the loop, we could certainly do that. Now we close the for loop, and I want to show you these two statements. So after the for loop finishes, I can print out the main variable. Since I told you the loop is going to run 5 times, we would expect the main variable to equal 5. So this is going to print 5 onto the screen. Look at my next statement though, printf, and I try to access this for var, which you might think, oh, well, here's for var, we've already defined it. It was set to 0, so this should print 0 onto the screen. But incorrect. This statement will not compile. If you try to put that in your program, the compiler is going to complain and say, you're referencing a variable that isn't defined in the scope in which you've referenced it. So you see here, this variable was defined in the scope of the for loop. Now we've exited the scope of the for loop, and it's no longer visible to the main program. It was never visible to the main program, so we can't reference it. So another way to think about it is, as we have these brackets that open up code blocks, any brackets that you embed inside of another set of brackets, okay, in that embedded code block, it can see everything outside of itself, but the things that it defines inside of itself cannot be seen on the outside. So it's like information only sort of flows down into the boxes. It doesn't come back out of the boxes. All right, now let's consider the idea of user functions. Now, again, normally we would define the user functions before the main function, but I've done it this way just to create a visual effect that the user functions are not a part of the main function scope because the main function has closed its brackets. So when you define these user functions, any variables that get defined inside the user functions are not relevant to the main scope. They're not seen inside the main scope. You can't refer to them. Similarly, variables that were defined in the main function's scopes, well, we can't see those inside the user function. So when I call my function, let's assume I've defined my function down here, my function can't see int equals main. It can't see for var equals 0. These variables aren't available to the user function. It can, however, see the global main variable that was defined at the program file level because variables defined at the program file level are visible to all functions, the main function and other functions. So this idea of scopes is going to be very important as we move forward, that a variable only exists inside of its brackets if we define it within the brackets. Okay? If we define the variable outside the brackets, it is still available within smaller sets of brackets that are embedded down in like a little Russian doll. Let me make one more point to you here. Look at this for loop. I set up a variable called int for var. I set it to 0, but I don't do anything with it. Imagine if I did do something. If I said for var plus equals 1. What actually happens? Well, is the for var variable going to equal 1, and then on the next loop equal 2, and then on the next loop equal 3, and all the way up until the loop's finished so that it equals 5? The answer is no, it won't. Because each time I execute a for loop, I re-enter the body of the for loop and everything starts again. I redefine the for var variable, I reset it to 0, and I increment it one time. Then I increment the main function variable, which will be incremented. And then I exit the for loop and I return back into it to do it again. As I return back into it to do it again, it's as though this for var variable has been destroyed and recreated. We have a new variable. The for var variable is reset to 0. It's a new variable now, and I increment it, and it's just going to be 1. So every time I go through this loop, I'm just going to create the for var variable, increment it to 1, and then I'm going to exit the loop. The variable is going to get destroyed, and then it'll get recreated when I come back into the loop for the next cycle. So I know that might seem a little confusing. We will continue to drill in the principles of variable scope as we do more and more exercises. But that's it for today. Let me show you quickly something I found on the web. It just maybe is a little prettier than my drawing. So up here we have this global variable, which is available throughout the entire program. It's available in all code blocks. Then we have the main function, and they show us here with this really pretty bracket and the number 1. The entire main function is a single code block 1. Then later inside the main function, if I open up brackets for whatever reason, a for loop, a while loop, whatever, a switch statement, inside here it would be considered a separate code block 2. And if I define int x equals 30 again, it's sort of like this new variable that I've defined in the code block sort of overshadows the variable that got defined before. Now this here is not altering, sorry, let me highlight for you. This statement in code block 2, it doesn't alter the integer that was defined in code block 1. It doesn't alter it. So when I exit this code block where I created an integer and set it to the value of 30, when I exit this code block here, integer will be equal to 20 again. So this integer and this integer are not the same piece of memory. They're separate pieces of memory that get defined and are only available in the scope in which they were defined. If I write a new variable in a more narrow scope that has the same name as a variable in a larger scope, it sort of overshadows that other variable name. And then here that we show a third scope, which is a user-defined function. We also have an integer named x defined here. It has no relationship to the other x's, but it will overshadow the global x. So if in this function I refer to the variable x, I will be referring to my local variable x, not this global variable x. So the principle here is, as I go deeper into the scopes of different sections of code, different code blocks, variables from the outside are available inside the block. However, if I define a variable inside the block with the same name as a variable on the outside of the block, the variable on the inside of the block sort of takes precedence. It overshadows the other variable. Now, this is not a great practice inside coding blocks to overshadow a global variable or to overshadow a variable defined in a higher level scope, but it does occur sometimes in programs and can be a reasonable programming approach. Just be careful not to create confusion when you're using variables with the same names in different code blocks. That might be confusing for the person who reads your code. All right, as always, I want to remind you, every one of our videos that we do has a companion program file. So the companion for this video is O8-functions. You can find that in my GitHub. And in this program, we define a few functions. We show you how to use those functions and how the functions can sort of do their job by simplifying the code, allowing us to use a function instead of repeating the same thing over and over again. I'll just highlight it for you here in line 66. Starting in line 66, we execute 3 if statements, and every single one of these statements does the exact same 3 comparison operations. We're trying to see if a product, a lamp, will fit into a box. So we check to see, is the lamp less than or equal to the width of the box? Is the length of the lamp less than or equal to the length of the box? Sorry, this should say length of the box. I have an error in my code. This should say length. This should say length. just to show you, it's very easy to make mistakes here when you are rewriting the same code over and over and over again. You're naturally going to do copying and pasting, and you're probably going to make mistakes. So here I'm comparing the width, the length, and the depth of the lamp to the width, length, and depth of the box. And then I compare box 1, box 2, and box 3 to see into which boxes will the lamp fit. Now the point of this is, from line 66 to line 80, I repeat the same 3 statements 3 times. So if I were to find a function that does this for me, I might be able to simplify the code so that it looks like this. I just call my function will it fit, and I give the function all of the parameters that are necessary to calculate whether this item will fit into, let me turn on my do not disturb here, I'm getting dinged, to see if the item will fit into each of the boxes. And the function does all of the comparisons for me. I don't need to rewrite all of the comparisons every time. So read through the file, see if this makes sense to you, how I can take a function and simplify my program so I don't have to rewrite the same code again and again. That's the main idea behind functions. And today we've seen how to define them. Thanks again for tuning in, and we'll see you in the next video.